Okay, welcome everyone to the DPRG's Robot Builders Night Virtual for October 7th, 2025. And we've got a queue going. So we'll start with DPRG news as usual. And then we've got a queue going, and then we'll jump to open mic. So DPRG news. Want to let you all know that I have engaged with Amazon Tours to try and set up a tour for the DPRG of the Amazon fulfillment facility in Grapevine, Texas, which has a bunch of robots in it apparently. It would be the standard tour like you can get, like Carl went on, but so it lasts an hour. It would be at 1 o'clock on a Monday. We're just trying to work out the date. That looks like it would probably end up being in December, possibly January, first week of January. I hope we can get it fitted in by then. Second thing is Doug published put up on the web the video and slides from last Saturday's DPRG meeting, the monthly September monthly meeting. And in the video, I've chapterized the video, and at 1 hour and 0 minutes 0 seconds is the beginning of Karim's amazing demonstration of Barney accepting verbal commands, spoken commands to move its camera around and describing what it sees and conversing verbally with the audience. So that was a tour de force and very impressive. So it's a pointer to go and check out on the DPRG website under news, the September meeting video, and go to the chapters, which you find in the description. If you expand the description, and in 1 hour you'll see clearly marked where Karim's robot starts talking to the audience. It was very, very amazing, impressive demonstration. And with that, let's move to the queue. And Mike, how are you doing with your awesome truck?
Oh, for some reason I just can't code as well as I thought I used to. So, it's just crazy. It's like I can't punch my way out of this paper bag, but I slowly get there. So the plan is to put the coordinates where the cones are supposed to be in a file, and then I'll have a controller node that reads the file and sends the localization to a navigator node, and then it runs to it. So I set that up, and I made a dummy coordinates, because right now I put the robot where it can't see the cone, and I put a coordinate in the file that brings it to a place where it should be able to see it. And so I'm going to demonstrate that. I'm gonna use my phone again, make sure I don't. Oh shoot! I forgot to get it ready. So. I forgot to get my phone set up. I wanted to show it. What? Going to the Dorg. Oh. I'm sorry. The there we go. So I'm set up with a phone now, so I can show my robot. I'm gonna put it in. Oh, here I am. I'm gonna swap it around. Okay. Okay. So my robot is in the corner over here, and the cone is out there in the hall. And for the robot's position, you can't see the cone. Okay. So that's sort of the setup. You might want to pin that. Then I'm going to share my FoxGlove screen. Share FoxGlove. Okay. And then I'm going to go and do the magic start command.
So Mike, can you set goal points in FoxGlove the way you can in RViz?
No.
Okay.
But I'm letting my file set the nodes.
Time of night node started. Camera inactive. RC25 navigation node started. Engine controlled by remote. Engine controlled by computer.
Wow, you got your speech to text working.
Requesting next node location. So the node one location equals 2.51 equals.
My video is not working.
And code up to next equals 4.84 wide equals 1.8 zero. Can lock code. And code up to next equals 4.84 wide equals 2.68. Take 2. Take 3. Take 3. No code locked up. Take 4. Take 5. Matter. Thank you. Copy now. Go to code to get another code location. Make 0. Make 1.
So right now, the it's sort of stuck in a loop right now. So I'm gonna go kill it. And when I look at Fox, is everyone still here?
Yeah.
Okay. When in FoxGlove, the window here is the command velocity, and so you can see that it traveled the longer distance to get into here. And then it did my pull-ins using, not using the navigator, but using my own commands. And then it backed up and then did it again, and it was stuck in a loop. The interesting thing is this this window here, the blue lines is my cone detected position or distance forward using the camera, and the red one is the same cone detected using the LIDAR. And
Wow.
and the cone and the LIDAR is 100 millimeter, 10 centimeters closer to the cone. So that's why these are off by about 10 10 centimeters. But you can see that they track pretty good when it's close enough to see the cone. But you know, the LIDAR cone detection, it's not very good until it gets relatively close. So the camera up here is detecting it at 4, and it can easily detect it at 8 meters away. And then so the navigator software pulled it in, and then at about 2.5 meters, the LIDAR was able to see the cone, and then it switched over and pulled it in, and then backed up, and then backed up to here, and then went and found the cone again and backed up again. So yeah, and then this window here is the I guess I'll just expand it, is the Y direction, the you know, sideways direction. So it was far away, and then it eventually got it relatively in front of it, and then it pulled it in, and then when it backed up, there's some sort of a bias where it doesn't back up straight and it goes crooked. Not sure what that is, but I don't really care. And then it pulled in again. So the FoxGlove plots are pretty good because I can make sure that the cone detector using both the LIDAR and the camera agree in terms of where the cone is, so that was a good debugging thing to be able to work on the code to get them to agree. And so now I'm pretty comfortable with them, that they work pretty good. Yeah. And if you notice this, I put a little just for fun, I put a battery gauge on my battery, so I can see it, whatever.
Nice.
And then the robot speaks the battery as the battery goes down, like it's at 11.5, and it's 11.4. Then it's danger, it's 11.1, or not. Well, it's warning, and then 11.0 is danger and stuff like that. So, all right, so that's my show and tell.
Nice. Hey, Mike, can you remind me, I'm sorry, I don't remember, how does your LIDAR identify the cone?
Okay, it has 3 validations. If I can pull up the code, I guess I could do it that way.
Well, I'm just wondering conceptually, because it's a spinning LIDAR, right? So how do you decide?
So basically, it's like, okay, I just want to look for something in a 45-degree angle, because that's what all my sensors are sort of. They're like, my camera has about that field of view.
Yeah.
I think it's a little wider on the camera, and my time of flight sensors have that. So it's okay. So basically, a 45-degree, and then it sort of looks for something and says, "Oh, that's something that jumped out of the background."
Ah.
Yeah, and then it says, "Oh, that's a star or something."
Between the background and something in the foreground are considered
and other stuff. Yeah.
Nice.
And then it goes through the different rays distances, and then when it sees another jump to the background again, it says, "Oh, what is that?" And then I do some validation on that. It's like, okay, well, the min and the max on it is only the width of the cone.
Ah, right. So range versus number of pixels or number of LIDAR.
Right. And then it's like, okay, how wide is that? And what is the width of the object at that distance? Because I know how many rays are hitting it. And if it's too big of an object, then it says nope. If it's too small, I say nope.
Right.
And stuff like that. Yeah. I just do a bunch of just testing.
That's awesome. That's the same kind of that's just exactly the same technique as I used on Minibot to find cans in the 6-can competition.
Mm-hmm.
Awesome. Gold star for Mike.
Yeah. I'm trying to figure out how to turn off my phone without hanging up on everybody like I did last time.
Nice.
Yeah. I hate leaving my phone going. That's crazy. All right. I just want to hang up on everybody. See.
Nice. Thank you, Mike. That was cool. Let's see. Pat had a question about ROS.
I had a question about ROS. I'm having some difficulties, and I will share my screen. Maybe a couple people more knowledgeable than me can help figure this out. So I have in this screen, I've got basically a Raspberry Pi. I'm SSH'd into my Raspberry Pi, and I run a Docker container. And so it's running, I forget what version of ROS. Anyways, it's running ROS 2, and I give it a launch command for LIDAR, and it starts publishing the node for my my topic scan. If I go in on this screen, same thing. I started a different container, and I look for the scan. I can pick up the scan. So that's from Docker container to Docker container inside the same machine. So everything is working fine. When I go to my home PC, and again, this guy is, so it's my laptop. It's the one that the screen background is on. And I run a container with the same version of ROS, but it's a full version of ROS. And so I'm able to bring it up. And if I do ROS to topic list, so I don't get my scan. I'm not getting my scan topic. So obviously I'm not communicating across through the network between the two. And I was wondering if you guys have had any experience with this to get it to communicate across.
Yes, badly.
And I think this is a Docker question.
Can you maybe run, I mean, this is just my theory. I know a little bit of Docker. Can you do Docker inspect and then see what network both of those Docker containers are on? What's happened is that I've run into this issue before where both of them are on just different networks. Docker inspect and the name of the image. So Docker inspect my bot image.
No, but you'd have to do that on the Pi where you use Docker.
Okay, well I can do it on this guy. Okay, so I got to be out of Docker to do it.
Right.
So my bot image.
Docker inspect and then yeah, the name of that. Yeah, it's going to give you a huge JSON of like all the variables. One of those should say the network.
Okay. So,
You actually do this instead. Do Docker network ls. So not it's going to show you all the networks that are available. Docker
not,
network ls. Look, see, yeah. I believe that's the command. So yeah, you have 3 different networks. I bet you what's happening is that one of them is on the unnamed network and the other one is on host. So do Docker network. No, my bad. I think it's Docker inspect and then bridge. I think that's how this works. Inspect bridge. There shouldn't be anything on this one, but we're gonna go through the list.
You had a misspell there, Pat. Inspect.
yes, I did. Which does not surprise me.
Scroll up. Okay, so you just have like the default. There's nothing on here. So do Docker inspect and then host. So we're just going to go through all the networks that were available. And then there's CanBot. There's that container. It's running on that one.
Yeah.
And now if you Docker inspect none. I bet you the other one is on there. They just can't see each other because they're on separate networks. Never mind. I'm not seeing anything on here. Is it because your other container's not running?
No, the containers can see each other, he said. It's the real PC that can't see the containers.
It's this guy that can't see anything.
So
Are the containers just like allowed to do local communication?
That I'm unsure of.
No, that's a question for the Docker expert who just spoke, right? Maybe the container can't get out of the Pi, or out of the container.
How are they communicating? Is this a separate is this all happening on the Pi, or is this on your personal computer?
The right and the middle screen are on the same Pi, and the left screen is on my local laptop.
Oh, you probably need to set up some routing. I've never actually done this part before. You might need to look up the Docker network. It seems like you're just having a networking issue that's specific to Docker. It's very likely that in the command where you're doing Docker run, you need to specify what routes it needs to take to communicate back to your computer.
Okay.
But those commands I don't entirely know off the top of my head. It's not something I typically work with.
Okay.
So I got two questions, Pat. The first isn't related to the networking communications, but it looked to me like you're running Docker start on in both windows on the RPi. So you're actually starting two containers, and maybe this is a question for those more knowledgeable in Docker than me, but I've typically used Docker start once to start a container, and then Docker exec minus, I think it's minus IT bash, which starts a bash shell within the running Docker container. Do you know about that technique, and is there a reason you're not using it?
No, I do not know about that technique. So what I was using is a Docker run command with a different image.
Oh, you got a different image?
A different image.
Oh,
so when I run on a different image, it's essentially like two PCs running.
Yeah.
And
some reason you want to run it on a different image?
No, I was just because I didn't know I could do a Docker exec.
So let me just find the instructions that show the command to do that.
So the whole point of this is not to run two on the same machine, but to run one on my host laptop. And be able to run RViz and laptop.
Right, I understand that, but it's still there are lots of reasons why you want to run multiple bash shells in one Docker container. For example, to on the RPi, you might run teleop, or you might run keyboard teleop in one bash shell and the main robot driver in another bash shell, and they can both run within the same Docker container.
Okay, so that's, so I'd be able to run the same CanBot image on both.
Yeah.
Okay. Is it the same command? Would it be just Docker exec-it?
No. So the first one you want to use, I'm just trying to find the instructions. Hang on a sec. First one, you need to use Docker run to get the Docker container running.
That's the one I use, Docker start -i CanBot. So CanBot is the container.
Yep.
And so that starts it up, and it starts it with the idea being that I have some persistence. So I have some files that I can keep in there every time I boot, and they're there.
Yep.
So it's there.
Okay.
So I use Docker start for that guy.
Yeah.
and then I run my launch file.
Right.
This other, the middle terminal, is the one where I was running Docker run on a separate container. And the only reason I was running a separate container image is because if I tried to run the same one with the run command, it gave me a problem both. Every time I typed something in one window, it would type into the other window. So I think you have it right where it would be Docker exec something to possibly get it to work on the same.
Yeah. Okay, I'll find the instructions for that here in a little bit. But moving on to the question of getting those the container to talk to your laptop. Run this command on your laptop. Let me just find it. ROS 2, that's right. ROS 2 multicast receive. So run that on your laptop.
Okay, so if I can run that guy. So ROS
2 multicast receive.
Did I spell it wrong?
ROS 2 multicast.
CIE?
Multicast receive. No, you spelled IE, it's EI.
Yeah. Spelling was never my strong point.
Okay, so this is a diagnostic command that's provided with ROS 2 that's lets you check whether DDS should work between two computers. Then inside of the on the other one you want to run it inside of the Docker command because you don't have I assume you don't have ROS installed on your Pi. Is that correct?
It's in a Docker container on Pi.
Yeah, right. So you need to start the Docker container.
So if I started this with this command, I start a separate Docker container.
Yeah, whichever.
It'll still, I think, should be able to receive.
Then do ROS 2 multicast send.
And just send?
Yeah. Okay, and you didn't get a message on your PC saying received a multicast. So that tells you that multicast is not getting out of the container and over to the PC.
Yeah, it's not leaving the PC. So it's getting from one container to another container.
Correct.
But it's not getting out of the local PC. It's not getting past localhost or something.
Right, and you can flip them around. You can do the receive in the Docker container and the send in the on the PC, and I think you'll probably find the two.
Did I spell it wrong again?
You'll want to run this
Oh,
ROS 2 multicast receive. I'm sorry, I think I said it wrong. Okay, so then
he's ready to pick up them,
go. Yeah.
and he got it.
Yeah, right. Now, if you try it from the PC, I bet you won't get it.
If I try here, Control C.
And fire up the receive again on the receiver because it receives one message and then terminates. Yeah, so that tells you where your problem is. Multicast is not working between the Docker containers on the RPi and the PC. So then the next thing you need to do is to check whether UDP is working between the Docker containers and the PC. And you do that with, what is that command? Encat. Encat. Let me see if I've got it in my history.
Ncat is exactly how you spell it.
Yeah.
NCAT. I'd have to install it.
Yeah, so install Encat. Yeah, and you'll need it in the container as well, which means you'll need to.
I got to rebuild the container.
Yeah. I don't have that command in my history, but I think it's Encat. Maybe I'm thinking, what's the command that you can use to send arbitrary streams to a socket? I think I might have the name wrong.
This guy.
Netcat.
Netcat. Okay.
Yeah. So on one container do NC. Oh, it's called NC is the.
Just NC.
Yeah, NC minus LU 3000, and that will create a listener. No, the command you don't want to put that into your Docker build.
Okay.
You really want to start a bash shell, but you probably don't have NC installed, so you'll have to.
Yeah, so if I want to start a bash shell inside Docker, I need to include NC.
Right.
So that's where I was going to put it in there.
Yep.
And that'll take me to a bash shell, I believe, at the end.
Yeah, so maybe we're digging in a bit deep for the group, but be happy to get offline with you. I fought this problem. It stymied me from January to about July this year, and it was exactly what you're seeing, where I couldn't get my laptop to talk to the Raspberry Pi to send ROS messages between my laptop and the Raspberry Pi, and I could get UDP. So there are a couple of things that went on, and one was access point isolation. So access points can have this this setting turned on of AP isolation, or access point isolation, which prevents one computer from talking to another on the same network. And they use that to prevent, like in a hotel, to prevent one user from seeing and interfering and snooping with another user's traffic.
Yeah.
So ping, whether you can, I assume you can ping the two. Well, obviously you're SSH from your laptop in, so you don't, AP isolation isn't a factor here.
No.
So I expect that you'll be able to run Netcat like NC minus L3000, and then there's an NC minus U. I'll find the commands after a little while.
Okay, well, maybe if you want to reach out, if I can reach out
Yeah.
after the meeting or tomorrow or something.
Yeah. So the sequence of steps that you need to go down is obviously first verify that you can get network packets from one machine to the other, which you've done. Then second, can you get UDP packets from one machine to the other? And third, can you get multicast packets from one machine to the other? And I ended up having to turn off access point isolation on a router I was using, and then turn on a firewall and specifically enable UDP on it to get that multicast to work. It was like seriously messed up.
Wow. Okay, I did nothing like this at all on ROS 1. ROS 1
No.
just worked.
Right. ROS 1 is great. It's easy to work. This DDS stuff in ROS 2 is just a disaster.
Okay.
But
All
yeah,
that to get LIDAR traffic is what I'm looking for.
right. Happy to work with you offline on that.
Okay, I'll message you offline and see if we can go without tying up a whole meeting for hours trying to troubleshoot through this. Well, thanks everybody. Thanks, Jason, as well.
Let's see. Okay, let's move to open mic.
I have a quick question. How's David Anderson doing? I haven't heard from him in a long time. I mean, he hasn't been in meetings. He hasn't been in the group. How's he doing?
Good question. I haven't seen him in a long time either. I will check on him. Yeah, he kind of dropped off the face of the earth. Sort
I
of.
thought somebody said he was active in the Seattle area robotics, Seattle Robotics Society or something, but I'm not sure. I haven't seen him either.
Yeah, it's a good. Thank you for the question, Chris. I've been thinking about him now and then, and yeah, he always brought a good vibe.
Keep it simple mindset. You know, sometimes it's just refreshing to have that perspective also represented. You know.
Yeah. I've got to stump the club question, and then maybe I'll ask Mark. I don't know if you're at a point where you can show your mods to the maker's pet. I'd love to see that. But my question is, it's really an ESP32 question. So the maker's pet has this ESP32 do it board on it, and I'm trying to port it over to linorobot. So it comes with maker's pet firmware, and that works great, and everything works, and it's wonderful. When I run the test motors command on the linorobot, I see the motors, both motors, spin forwards and then backwards. One at a time, forwards, backwards. The other one forwards, backwards, like it should. But encoder counts only change on the left-hand motor, not on the right-hand motor. And so I stuck the scope on it, and let me see if I can, bring up the schematic. And let me share the schematic. It's not what I want. Sorry. Presenting window. Okay. So what I found was, are you guys seeing this schematic? Probably a bit small at the moment, right?
Yeah.
Is that better?
Yep.
Okay, so EA write. Let me see if I can pan around on this. How do I pan? There we go. So here are the motor connectors, and EA is EA left. That's encoder output A left, encoder output B left. So the quadrature encoders, and the same for right. And that goes up to here where EA right, EB right, EA left, EB left go through a 10K resistor to enc A right and enc left and enc A B left. And those are connected to the ESP32 here for the left side on pins 2 and 3, which go to GPIO 36 and 39. And then on the right side, enc A right, enc B right are connected to GPIO 16 and 17. And so the problem is that when I put a scope on the left side, which reports counts, it reports the RPM from the left motor when it's running, I see what you'd expect. So I see a TTL level signal, so like 0 to 4 volts on EA left and EB left, and that becomes 0 to 3 volts on NK left, NK B left, after it's gone through the 10K resistor and been applied. Presumably it's being clamped by the overshoot diodes in the IO pin on the ESP32. What I see on the right side is I see, let's see, I don't remember what I see before the resistor, but on the ESP32 side, I see an encoder waveform, but it goes from like 4 volts down to 3 volts. So it's a, it's like a square wave modulated on both signals. So there's quadrature encoding coming through, but it's like it's being driven high, like it's being, like either there's an output, like maybe GPIO 16 and 17 are configured as outputs, perhaps driving high, and the encoder is unable to overdrive them more than getting them down to 3 volts, which and so I'm like at a loss. I've gone through all the config files in linorobot to see if I could find anything using UART2 or anything using GPI 16, 17. So looking for like suggestions for stuff to look at to try and find out why.
Can you power the encoder and twist the wheel and see if you get decent levels out of the encoder? Does it go all the way to ground, or in other words, isolate the processor from the encoder and see if it still exists.
I haven't done that. That's a good
Yeah.
spot. I was assuming that worked because it works using the Maker's Pet software, but you're right. I should verify that.
Yeah, that's a way of isolating, you know, is it the output of the encoder or the input to the processor? Who's it
Yeah,
for?
yeah.
Yeah.
So what I'm wondering as well is, does your encoder have maybe a pull down resistor or a pull up resistor, and your input pins have the opposite?
So the left and the right motors are identical, and the electronics on the board for left and right are identical. So it shouldn't be an incompatibility between the encoders, like the design of the encoders.
Can you explicitly pull the pin or remove the pull-ups in the software, in the firmware? So what I'm wondering is if it comes up by default with the UART2 enabled.
Yeah, yeah. I wonder.
And so you're using the GPIO pin, but it still has an internal pull-up or pull-down resistor enabled.
Yep.
And you're getting a weird voltage as your signal changes.
So did you say it went between like 5 volts down to 4 volts?
Well, 4 volts down to 3 volts is what it looked like.
Okay.
So I was wondering if maybe between the encoder and the input pin configuration, that is creating a voltage divider and giving you the weird voltages.
Well, you do have this 10K resistor in line between the encoder and the microcontroller. So
Well,
that would.
The thing that I understand is that part doesn't like anything either above 3.3 volts on an input or below 0. So that sounds like you got something really squirrely.
Yeah, yeah.
Yeah.
I mean, if you see 5 volts on something, that sounds like you're going to blow something.
Right.
Yeah. I know they do have some input protection, but there's limitations on what that can do too. I mean, it can probably, sink a few milliamps, but not much more than that.
I thought I read somewhere with them that at 3.6 volts on an ESP32, that was it, you're done.
Yeah, they can be pretty sensitive on the inputs. Yeah.
Yeah, that's
I was
understanding is that more than the 3.3, which is the supply voltage, you're going to zap something.
Yeah, you latch it with a latch and you're done.
Yeah.
Yeah.
On an encoder topic, I found that the little DF robot TT motors with the encoders, all the documentation I find on these say they run at 5 volts. And I was looking at putting level shifters to bring them down to 3.3 volts and all the such. Well, tonight or this afternoon, I broke out my last year's Christmas present, never used it, an oscilloscope. So I put it on the connections and I powered it from 3.3 volts. And lo and behold, I'm getting 3.3 volt quadrature signal coming out.
Yeah, those motors and most encoders will work on 3.3 volts just fine.
Yeah, but all the documentation, all the examples, everything I find on the net show them with 5 volts.
Yeah, because they're running it with an Arduino, which accepts 5 volts.
Yeah.
Yeah.
So,
but anything that's STM or ESP or any of those, anything over 3.3 volts or whatever the supply voltage is you're providing it equals smoke, the blue smoke coming out.
magic blue smoke. I have a can of that in the garage to fill back up.
Dave, you would know much more than I would, but I thought they used to do like a diode on the input pin to VCC and then
Right.
Yeah,
You know, and then
have ESD protection with diodes to power and ground, but
yeah,
I wouldn't trust them to handle anything.
yeah,
Just don't
very
test
small.
don't test them that way.
Yeah.
Paul, why is there a 10K resistor in series with the pin between the encoder and
I think it's meant to drop the voltage down, but that's not a good way of doing that. That's for sure.
Well, it's good for those to have those resistors there as protection, but I don't trust anything.
Yeah, is it a current limiting thing, you know, to limit it down to 5 milliamps or something, or is it a voltage thing where you're trying to create a voltage divider to run 5 volts in?
Well, you can use them to some extent, and with a 10K there, yeah, you'd be limiting it to what, a half milliamp or something like that with a 5 volts. But I just don't trust those diodes to be very beefy.
Well, it should be less. It should be more like 0.1 milliamps, right? Because if you got 5 volts coming out of the encoder and you got a diode drop above VCC, above 3.3 on the as the protection on the input pin of the microcontroller, so let's call that 4 volts. You really have 1 volt above across this 10K resistor, so you'd have 0.1 milliamps that could flow into the protection diode, right?
No, well, okay. If it was a 1K, you would have 2 milliamps flowing, okay? So 10K is 0.2 milliamps. 5 volts to 3 volts.
Yeah, to 3 volts, but I'm saying that 3 volts isn't the actual limit. The actual limit of how high it'll go is the over voltage protection diode that will become forward biased to 3.3. And so that has a voltage drop of 0.7 volts. So really 4 volts is as high as that pin should go before, you know, smoke starts getting let out if you're not putting enough current through it.
Yeah, but okay, so you're talking about 0.1 milliamp, but still, you're okay.
I think that's how this circuit is working.
But
Okay.
but do you think those protection diodes that are built in the chip, do you think they're more for hobbyists like us that are miswiring by design by accidents, or do you think they're more for like handling and static discharge? I got the impression
more for handling and static discharge.
Yeah.
And I don't think, that's why I say I would not depend upon them for any useful purpose.
Well,
They're not for
think that's
bulk
what the
energy
design
dissipation.
does. I hear you, Dave. I hear you, and maybe you could say it's not the best design practice, but I think that's what's going on here.
Well, it could well be what's going on there, but I'm just saying I'm really leery of the magic blue smoke.
Yeah.
Did you say your encoders work at 12 volts?
No.
Okay, 5 volts?
Yeah.
Oh, okay. I guess I misheard you. Yeah.
Can you drop that to 3.3? Would they work?
Really good question. And
I can send you my oscilloscope.
Yeah, I'd say, like Pat was suggesting, I'd run them off of whatever the supply voltage is that you're putting into the ESP32.
Yeah.
well,
Not
that's
anything else.
yeah. So that's a really good point. So here's the motor connector, J2 and J3 as examples, and you've got the motor pins M1 left and right on 1 and 2, and then you got ground. The other 4 pins have to be for the encoder. One's hooked up to ground, which you expect. The other's hooked up to Vinc, and Vinc.
Oh, look at that! You have a jumper selection there for
VREF is
5 and 3.3.
Same as you're running into the processor.
And I think this jumper, at least the schematic, looks to me like they're saying the jumper is set to +5, and
Looks like it, yeah.
you'd wish it was on +3.3.
Get a little X-Acto knife, cut the bridge between
Yeah,
5 and V encoder, and solder it between V encoder and 3.3.
Yeah,
that would be good.
cut that and solder the 3.3.
Yeah.
That's a great point. I'll get back to the designer at Maker's Pet and say, hey, what about this? Thanks for that suggestion.
That's assuming those little N20 motors will work with at 3.3 volts.
Yes, absolutely.
Yeah, David said that those encoders typically work at all sorts of voltages. So
That's right.
Okay, well, thanks, guys. I'll try disconnecting the encoder and inputs and see if I get decent outputs out of it.
Yeah, it's probably the quickest way to figure out, is it the encoder or is it the processor pins?
Yeah, and if the microcontroller is set to be in output, I don't know how I'm going to find that in the code. But I guess I'll deal with that when I get to it. Okay. Thanks.
What was the code written in?
It's on the Arduino platform, so it's Arduino C++.
Oh, okay. They probably have input mode, comma pull up for that pin. Yeah.
Just say to hell with it.
in a
To hell with
config
it. Throw it at GPT. Say, hey, GPT, look at this code and tell me if I've set this or not.
Well, that's a good idea. That's a great idea.
It's a large language model. Just say to hell with it. Let the machine sift through it all.
That's right.
Great idea.
Burn a few kilowatts. What the heck?
I mean, I'm so lazy. I don't bother troubleshooting crap anymore. I just throw it at the... And it does a remarkably good job.
What did I do wrong here?
Yeah. Although it takes the fun out. It's like you don't have to know anything more except how to ask a question.
That's right.
Well, I'm the guy that can't spell, so spelling matters as well.
No.
The trick is asking the right question.
That's the hard part.
That's a great idea, Carl. Thank you. All right. Mark, you did some cool improvements to the Maker's Pet. Is that something that you're in a place where you can show?
No. No, I could probably show you the software side of it, but that's more of a TED Talk Saturday probably than a Tuesday night meeting.
Okay.
But yeah.
All right.
But it's coming along. I mean, the improvements are really, really useful. Like having the magnetic LIDAR attachment, just like popping it off and getting to the, it's just, yeah.
That's an awesome idea.
I can't pick it up because it's connected. I'm updating the software too. I'm working on the pet. I'm working on adding multiple Wi-Fi stations so it can search through the Wi-Fi and it's like, oh, I'm connected to this one, and then it sticks to that one.
Oh.
So, let's see if that works. I don't know if it's going to work or not, but we'll see. It's just playing around with it.
Cool. Did you try out that USB cable with the right angle connector that you told me?
Yeah, didn't work.
Didn't work?
Nope. No, it would have gone straight down into where the motor connector is.
Oh.
So if I'd gone a straight one, like, okay, so the one I have on here right now, let me discount this. It's just going to show on the camera, but nope. Yeah, see, I have a, let me move the battery out of the way. I have a right angle one right now that works. And actually, I can put the LIDAR back on there. Oop, nope, put it right around again. I can put the LIDAR on there and it doesn't hit the cable.
So I can technically have a cable in there and the LiDAR, but yeah.
Yeah, I found I could do that as well
Yeah.
with a straight
So
connector.
that's been my best option so far.
That's so nice being able to
It is.
put the magnet,
And having
put the LiDAR on with a magnet.
and having the solid block instead of the 4 little individual
Yeah,
connectors. Oh,
yeah, nice improvements.
yeah, it's such a time saver. But it's a good little pet. I'm having a lot of fun messing around with it and learning. I'm learning a lot of ROS with it too, and Docker.
Oh, yeah?
Stuff I don't normally play with. So I am learning a lot. Whether it's staying in my head, I don't know, but I'm learning.
Cool.
Yeah. But yeah, I've been messing more with Onshape and Blender and yeah, just engineering 3D prints and having getting my micrometer out and just getting really accurate 3D prints, and that's a lot of fun too. So, yeah, it's good times.
Fun toys.
Oh, I did have one last question, and this is something that you and Mike hit like a couple months ago, where you both had the same ID or something, and you're both interfering with each other. Remember that?
Not the
Is that
same
something?
IP, but the same
It wasn't IP. It was what was it?
topic names. Because we had there are standard topic names, like command /command-val, and since we were on the same network, and we were using the same ROS ID.
Okay, that makes sense. Yeah.
What's supposed to distinguish different robots. We ended up sending each other. Mike, you're on mute.
So the ROS ID.
ROS ID would be one way to fix it.
Okay. Okay.
Mike, you're on mute. If you're trying to speak.
But that or unique topic names.
Yeah, I was looking at it, and if you have multiple robots on one ROS ID, then you got to give them a namespace by prepending something to the topic names and stuff. But that's a lot of stuff to manage. But if you're just worried about my robot on the same network as someone else's robot, just make sure you have a unique ID, ROS ID.
Okay, good to know. Yeah, now I'm getting more into it. I'm like, what do I need to look out for? That'll be one of the things to look out for.
So I guess that'd be a thing that could, take you out at a competition. You show up and you've got all these, it's I don't know why it's not working. It worked at home.
Yeah, that happened at one of the show and tells with me and Paul. Yeah.
Yeah.
Okay.
Yeah, we figured it out before competition day, so that was good.
What else? Has anyone run across?
I'm just looking. Is there a maximum domain ID? So standard ROS domain ID equals 0 or 1. Is there something stopping you from using 1002?
I think so, but I don't know what.
Oh.
Yeah, I just gave it my birth date or something. Yeah, it's sort of random,
like a big number.
Yeah.
Okay, well I'm just wondering. Oh, here it is. ROS domain ID equals 0. Domain ID can be an integer from 0 to
65, 535.
No, 232.
Oh, 232. Oh.
0 to 232.
Okay.
Yeah.
Oh.
So just answered my own. Avoid using any domain higher than 100 unless absolutely necessary. That's on a ROS cheat sheet.
Yeah.
Oh.
Yeah. So I use my birth date day. That's right.
Hmm.
18. Just
That's right.
Yeah.
0 to 101 inclusive is what the
I just pasted it into
Yeah.
the chat, the cheat sheet.
Thanks, Pat. I was going to ask about that.
So I was just curious because exactly that. I tried. Okay, I made sure I had a ROS domain ID set to make sure I could try to communicate across. And it's okay. So if I pick one, and Paul picks one, and Mike picks.
Yeah. Yep. It's going to be interesting.
Yep.
Of like a swarm network.
It wasn't good when Mike and my robot were interfering with each other. We were both scratching our heads saying, what? It used to work.
Demo mode never works. Aside from that, I am in the middle of a teardown. So I have a little RP2040 0 board. And on top of that is going a little motor hat. And on the other side is going to be my Raspberry Pi and a LIDAR.
Oh, nice.
So I'm trying to get all of the robot control off of the RP2040, the Pico essentially, so that everything runs MicroPython for controlling the motors and whatever else. And then all my high level stuff is in the Raspberry Pi, which is only going to send what it thinks the command should be to the MicroPython. The MicroPython will have the arbitrator and decide what to do with all of the values.
Can you hold that up again? Because I didn't get you pinned until like right about when you put it down.
It's basically just, I made my own frame. I copied what they had, 3D printed some motor mounts. I have a little RP2040 Pi 0 control board on there. And it will use a little Pi 0 hat. So it's just an I2C interface to just a little motor controller. I don't know if my soldering skills are good enough, but I'm looking at pulling one more signal off of the PCA 56. I forget what it is, the little square wave controller, and to pull one more signal out for a servo.
Oh, those used to have a couple servo outputs on them that were like off on the side.
Yeah, no, they don't have, there was no servo outputs on this guy.
Oh, okay.
But I'm trying to get everything small enough to fit everywhere in there with putting a little LIDAR on the top. So I'm trying to make some more room. That's why I've gone to a redesign. And hopefully this will work out. And like I say, I sort of dropped out of the Robo Columbus because I am concentrating on a spring contest to make sure I have a robot ready to go. So I have many months to work on this.
Excellent.
So
That looks like a fun little robot.
it is. It started off as one of those little acrylic bases, and then every time you dropped it off the workbench, it cracked. So I ended up using foam board, Sintra foam board, and I just traced the outline and drilled a few holes, built a cam grabber from the old robot, and that's where I'm at. So hopefully it gets into shape soon. I'm glad I broke out the oscilloscope today and I checked the encoders and they're working perfectly fine. So I'm going to use a PIO routine in the MicroPython to read the encoders, so I don't need to worry about interrupts, and go from there.
Nice.
That's about it. That's what I've been working on.
Sounds like you'll be good competition.
Well, I'm hoping to be, because that's, you know, I don't think I would have been ready because I was busy till near the end of September with work, and it's not getting any lighter. I've been doing a lot of estimating for work. So I said, well, let's aim a little farther out. So I said, okay, before I get all frustrated, let's just forego the fall competition and let's concentrate on the spring one and make sure I'm ready to go. So I have lots of opportunity for testing and learning. So hence the delving into ROS 2, because I was thinking about firing up ROS 1 and doing it that way. And I said, I might as well just learn ROS 2. I've got enough to, you know, get the basics going. And so I'm looking at using ROS 2, LIDAR, and I'm not sure yet if I'm going to use OpenCV with it as well. So thinking about using OpenCV to analyze the ROS image. So it essentially puts out an image of when you've got your LIDAR map out. So if I see the cans or whatever, and I detect semicircular shapes in OpenCV, I detect the goals in OpenCV, then I can, you know, it becomes a little easier to try to set targets and that sort of thing.
Because Paul used just LIDAR to detect the cans. Just looking for the signature of a can.
Yeah.
Yeah.
That's exactly it. So you're looking for a signature of something, and that's where I thought OpenCV, what I'm hoping to do is to be able to spot the signature of 6 cans. So your robot is in the arena, you fire it up, boom, you detect all your semicircles, and you have the location of 6 cans, you know, hopefully immediately tracked in memory. So now you're not always searching for can, you know where it should be. So just an idea I had, and I wanted to see if I can.
You can optimize your path to get them out, get them fast.
Yeah, well, if I had whatever 2 centimeter squares or whatever in a grid, however I map it out, 1 centimeter squares in a grid, being able to basically say, okay, well, hey, I've got a can at this location, this location, this location, this location. So let's go, you know, clear out the board. So now I'm not so much worried about where the cans are as essentially maybe object avoidance. Don't knock the cans over.
Something that I think you'll want to do is what Mike described earlier that he's doing with the cone, is to put some boundaries on how many pixels or how big the curved image of the can should be based on its range. Because without that, I found when I was testing the LIDAR can finder, it would like take the edge of a course, like the end of like the board that where the board that was like the side of the course ended, and take that curve and call it a can.
Or like the edge of the goal.
Yeah.
Okay, that's hopefully the idea is to be able to follow the curve as opposed to a corner with the rate of change. And I'm not sure, but I think a Hughes transform could do that.
Yeah, I found when I was looking for my cone that I wasn't successfully getting a good curve on the cone. As it moved to the side of the cone, it was sort of distort, and it just got really hard to process. So I wasn't trying to fit a curve to it or anything, because that seemed like it was outside of the precision of a LIDAR on a curved surface. Like a flat surface, it does really good, but when you put a curve onto it, it acts strange at the boundaries when the side of the cone is not reflecting well. So
yeah, and I want to see how it works and how small of a curve do you need to be able to detect it as a circle.
Right. Yeah.
Well, the first part is getting the LIDAR working.
Right. And then you get the LIDAR working. what's a good reliable detection validation of this stuff that I see? So I put 3 things on it, and Paul put a couple on his, and the curve is another way to do it. So yeah, we can compare notes.
Yeah.
See which
Yeah.
one works.
So, yeah, I've got a routine I found, and it was using a Hughes transform to detect essentially semicircles.
Wow. Yeah.
And it's something that OpenCV does, very quickly.
Neat. Okay.
Wow.
That's
So
cute.
that's why I thought of putting the two together. So you take the LIDAR map that you create with the LIDAR program, and then basically you analyze the image with the OpenCV. So the OpenCV could track your goals and the goal at the end and where the locations are.
That's a novel approach.
Pretty neat.
Well, I'm good at novel approaches. The problem is the implementation. So that's why I'm working on months for implementation.
Right. So, yeah.
So
Sounds like it'll keep you busy.
Oh, definitely. So my desk
So-
was a disaster.
Yeah, so for Robo Columbus, obviously I'm making a new robot. Is anybody else making a new robot, or are they just dusting off their old ones and trying to beat me?
Oh, the gauntlet was thrown. Tom, have you got anything going on these days? Oops,
You muted, Tom.
you're on mute, Tom.
It's not robot based. I'll show you a little bit of work in process I have. Hold on a second. I had decided a while back. I have this really crappy doorbell system in my house, and I thought, God, I should be able to do better than this. So I should be able to put a computer in it and be able to program it and play whatever music my wife chooses for the front and the back door. So I had a bunch of bits and pieces from the old thing. You can see bits and pieces of it here. A speaker goes in that hole normally, and batteries go in there, but that's not what I'll use. So all the guts are gone. So a secondary goal was it's important to use that little blue thing, which is it's an ESP8266. It's a Wemos D1 Mini, right? I have a bunch, and I got to do something with them, and that just seemed like a big improvement over some of the online versions of a doorbell system I've seen that run with Arduinos. This should be easy, right? Well, the ESP8266 does not have hardware I2C, and that other little gadget next to it is a lovely 12-bit D2A converter that'll go really, really fast with I2C, but not with an 8266. The software looks good. It just doesn't run anywhere near fast enough. So I looked through my collection of interesting things and said, I don't have any really, really fast D2As. So I built one. So the upper half of that circuit board contains a very fast 8-bit shift register and an R2R network. And the bottom half simply drives an audio amplifier. So that will be the very high-speed D2A converter that will let me use basically sine wave outputs and some MIDI software that other people have already put together in order to implement the doorbell. The rest of it, the rest of the stuff that's on that little board is simply some hardware filtering for the input push buttons. And then the whole mess fits kind of neatly inside the back end of this package. The remaining circuit board that's in there is simply what's left from the initial stuff. You'll see a row of really intriguing terminal strips down the center there. So that's a nice mechanical thing. I hate mechanical stuff. So I'm reusing the terminal block structure that was built into this plastic case. I've stuck in a connector for a plug-in power supply so it won't run off batteries. And of course, the mechanical stuff I hate, so it's taking forever. The rest of it I expect will run well, but I've just been fabricating the board today and yesterday and fiddling with bits and pieces. So I have yet to test it. I'll test it tomorrow. But so far it's looking much, much better. The shift register will probably clock very nicely at 10 megahertz. And the 8266 does have hardware SPI. And I intend to use the SPI basically as a hardware synchronous serial output. I tend to program in the Arduino development environment, which supports this stuff reasonably well. So we'll see. Not a robot, but a lot of interesting bits and pieces. And it might even be useful in the household. So we'll see where that goes.
Are you going to incorporate fingerprint identification so you know who's at your front door? Yeah.
No, and I don't do ring phones either, ring doorbells.
I like your unspoken remark. It might be useful in the households as opposed to robots, which are not.
And the musical choice should be quite extensive, since it basically implements a MIDI player. With luck, I'll have probably up to about a 10 kilohertz audio range on it. So it ought to do not a bad thing with short bursts of MIDI tunes and some push buttons buried inside to allow you to select what you like to hear. We'll see.
Fun project, Tom.
Yeah, it's fun. It always takes a lot longer than you think it will. This was going to be a one-day project, right?
Everything does.
Maybe you could incorporate like some elevator music, to chase away people that you really don't want to talk to that show up at your front door, just please hold and then just keep on playing it.
There's a thought, yes. That the fingerprint identification should come in handy there.
There you go. Yeah.
Who pushed the button?
All right. Do we have anything else? If not, is it time to wind it up?
Play the video?
What?
Did anyone play the video that Ed posted? Optimus Optimus robot.
Oh, I wanted to ask a question about your Amazon tour. You mentioned it'll be the fulfillment center in Grapeville. Is that what you said?
Grapevine. It's
Grapevine.
Metroplex.
Are they using drone fulfillment yet?
I don't know that they're using it in the DFW Metroplex, as far as I know.
Okay. They only have one pilot running in Texas that I know of, in College Station. But when I looked up earlier on their website, they're planning 22 more installations in Texas and are working on them now. And I just wondered if that was going to be one of them. Some of you may have heard of the recent problem Amazon had with their drones, where they collided with a construction crane cable and crashed to the ground in adjacent parking lots. So I read up on their drones. They weigh 80 pounds.
Whoa.
And they have a 5-pound capacity and a 6-mile range. Kind of intriguing. Not everybody can use them because you have to have a backyard big enough to dump the package into from the drone, because the drone doesn't come that close to ground. So you have to qualify before they'll do drone deliveries. But an 80-pound drone, for goodness sakes, it's a monster.
Yeah.
Who designed this thing? Is it NASA? They're the ones that build a 1 million-pound rocket to take 5 pounds into orbit.
Probably the Ukrainians. They have the most experience with drones now, I think.
But they don't overbuild them. They build them as simple and fast as they can.
I saw a drone doing a delivery in a neighborhood that I was driving by. I was just driving down the highway, and there was this, and I think Wing is their name, that's operating in the DFW Metroplex, and there was this drone, about probably 50 feet up in the air, and it had a cable. It lowered this box on a cable down to the ground, and then I didn't see the end of it because I'd driven by.
Walmart is a little bit simpler. They tip this 80-pound drone kind of up close to one end and they open a door in the back and your box falls out. That's how they
Really?
look.
Well, they were. I mean,
No.
the Walmart is around here because there's a Walmart up near my house in 121 in Josie, basically. And for a while there, I haven't seen it lately, but they had a setup in the parking lot where it was roped off, and they had all the equipment and tents, and so I know
Yeah.
Walmart's around.
Walmart drone delivery process apparently is much more advanced than Amazon's is at this point in the US. So you can ask when you do the Amazon tour where the drones are. They're
How's
very
your
big.
lake-
They're the size of a refrigerator almost.
Wow.
How's your lake doing, Carl?
We could ask that question at Amazon. So, hey, what about Walmart's? We don't like to talk about that.
Oh, it's coming along. It's just it's going to be some weeks before I can walk again to retrain muscles starting in November.
Oh,
Until then, no body weight on the left leg.
oh.
What happened?
Oh, I did a number.
Oh, bicycle.
Yeah. I went down hard. Must have been 14 miles an hour to 0 in the space of one hip hitting the ground. So I blew out the hip bone pretty well.
Ooh.
But it's coming along.
Good news.
Sorry.
We'll get you back on an electric bicycle soon here, and then
Yes.
work up to a manual bicycle later on.
February.
I don't know. You may want to switch from the bicycle to the biggest pickup truck you can get. Defensive.
Wear a big airbag or something.
All right. Have we done everything for tonight? All right. Good
All
talking to you
right.
guys as always.
All right, bye.
Okay, good night, folks.